So lesson number 7, we're going to be approaching trigonometry in a new way in this lesson. So this should be all brand new material for most of us. I would assume unless you took 11U last year. We're going to be looking at rotational trigonometry, that is trigonometry that goes around in a circle. So there's some things that stay the same, but there's some things that are going to become new when we do this. For the first example here, I want to calculate these things. I'm really just using my calculator, sine 60. If I punch it on my calculator, it comes out to 0.866. Okay, straightforward enough. If I try sine 120, strangely enough, it also comes out to 0.866. Okay, it's strange that we can have two different angles, very different angles, and yet they come up to the same answer, right? So that's kind of one of the ideas we're going to be dealing with as we work our way through rotational trigonometry here. Again, if I try tan 45, it comes out to 1, and tan 225 also comes out to 1. Again, two very completely different angles, and yet they come out to the same answer. So we're going to have to discuss that and figure out why that is. If I want to work backwards, I want to find x in this case, and I have the ratio. I take the inverse of that, right? Inverse of 0.5, and it turns out that x is 30. Okay, well, obviously, sine of 30 is 0.5, but if I were to happen to plug in my calculator the sine of 150, you might notice it also comes out to 0.5. And yet my calculator couldn't really tell me that. So there's a bit of a problem here, right? We're going to have to think about this. Okay, so some problems here, and this is sort of what rotational trigonometry will do for us. Okay, calculators are only programmed to find that first angle, the acute angle, if you will, the 30. They can't tell us 150. They can't tell us both answers, especially. Okay, so we have to have this new process we're going to have to deal with to figure this out. So the straight line trigonometry we've been doing, SOHCAHTOA, we've only ever had one right triangle. We talked about elevation depression. Every answer is positive. We had the SOHCAHTOA rule. Now we're going to take that and we're going to determine some new ideas that go with rotational trigonometry. Rotational trigonometry refers to things that are on the Cartesian plane, on the xy axis. If you look at the diagram over here, we have a x here and a y here. And as we go around the axis, we make a circle, if you will. Okay, we rotate around the origin. Usually when we rotate, we go counterclockwise too, just to point out. Okay, so we're going this way, round and round and round. Because of that, and because we're on the Cartesian plane, we could have some negative values. Things over here on the left-hand side, -1, -2, -3, -4, or down, -1, -2, -3, -4, could cause us to have a negative answer in this case, which we never could have when we did SOHCAHTOA. Okay, so some definitions. Where we start, we call it the initial arm. That would be the blue line in your diagram. Where you end, that's where it terminates. That would be the red arm in your diagram. And if you take that diagram and you turn it into a triangle, a triangle right here, like this, okay, you end up with something that looks kind of like this. You have an x direction. Remember, this is your x-axis, so the x direction right here. You have a vertical direction, a y direction, if you will. That would be the y right there. And because we're going round and round in a circle, this diagonal would be the radius of that circle, or r. Okay? The nice thing about that is x, y, and r are part of the Pythagorean relationship. X squared plus y squared is r squared. So if you know any two, you can figure out the third one. If we take this triangle, this one right here, and we think about SOHCAHTOA with that, the sine of our angle would be O over H, right? Well, in this case, O is Y and R is H. So we're going to build a new ratio today. We're going to call it sine of the angle is Y over R. If we took cos of our angle, A over H. Okay, A would be the X. H is still your hypotenuse, so A, H, and O. Okay, and that builds a new ratio for us. We call it X over R. If we do the same thing for tan of our angle, which is opposite over adjacent, in our case, Y over X. Okay, we get these three new ratios. Now, they're not new, really, they're the exact same. We're just using different letters. And those three letters form a new acronym, if you will. We're going to call that acronym Sir Sixer Tix. And some of you might be wondering, well, why do we have to make this new ratio if it really is SOHCAHTOA? Well, part of it is we're going to come across some situations where SOHCAHTOA won't work. where we don't have an opposite or hypotenuse or an adjacent, but we have an x and a y and an r. Okay, so we have to use this new idea in a different way. Okay. If we look at the first example here, okay, I have a terminal arm. Okay, so I started somewhere along here. That was my initial arm, and it rotated around to here.
Mr. Dronko, contact the main office, please. Mr. Dronko, contact the main office.
And that's where it terminated. And I want to find the exact value of each ratio. In other words, I want to find Sir Sixer Six. Okay. By giving a point, I've been given an x and a y. The x direction is this part. The y direction is that part. The only part I'm missing is the radius, the r. And we said a second ago we can use Pythagoras, a squared plus b squared equals c squared, or x squared plus y squared equals r squared. Now be careful to put brackets around the -4 because we want to square the sign and the number. If we put that on our calculator, we get 25 for r squared. We square root that, and r is 5. There's the radius of my circle. So if I were to write down the ratios based on that diagram, my sine ratio, the sine of my angle, will be y over r. Right, we're using this. So y, and we said was 3, so 3 over 5. Cos would be x over r. In this case, it happens to be a negative, and that's okay. We can have negatives in rotational trigonometry. And tan would be y over x. So 3 over -4, which you could just as easily write as -3 over 4. The negative sign doesn't matter top or bottom or in front, just the fact that it is a negative. And that's all I want for this. I want to find the ratios, the exact value of the ratios. I don't want the angles, just the ratios themselves. If you want to try the second example yourself, give it a try. You're going to have to draw it this time yourself and then fill in the parts and pieces. So we have coordinates. 9, that would be your x value. So I have to go over 9 and then down 30. Okay, so over 9, down 30. There's where the arm would be, right? It's rotating all the way around till you get there. So 9 and -30. X is 9, y is -30. And to find r, 9 squared plus -30 squared equals r squared. Put that all in your calculator the way it looks, and you'll get 981. Make sure you square that negatives too, right? And so r will be the square root of 981. Now, unfortunately, 981 doesn't square root nicely. So we leave it. It asks us for the exact value, which means I can't change things to decimals. I can't round them off. I can't simplify them unless they come out to nice numbers. And root 981 does not. Okay, so if I want my three ratios, the sine ratio, sine theta equals, you want your y value, in this case -30, over your r. We just calculated r to be the square root of 981. Okay, cos theta is your x value. X value is 9 over root 981. And tan is y over x, which is -30 over 9. And if you want to, you can reduce this one. They're both divisible by 3, so -10 thirds. A little bit nicer to work with. Okay, and that's how we can draw and put things into rotational trigonometry.